Okay, so efficiency tells us what percentage of energy put into a device is used usefully. So you can talk about the efficiency of an engine or of a kettle or of a hairdryer, of anything that uses energy, and it tells us how much is used usefully. Okay, now this is an important concept to think about. So we've got here two lamps. I've not drawn them, but we've got the idea of a lamp. Now a lamp, the useful energy that comes out of a lamp is light. Okay, so for us here, the useful one is light for a lamp. The unuseful one, the wasted energy, is usually heat. You can feel, if you put your hand next to a lamp, you can feel that it's hot, okay, because it's giving out light and heat. So the light is the useful energy, but the heat is the non-useful energy, the wasted energy. For something like an oven or a toaster, it's the other way around. A toaster, the useful energy is the heat, but you can see that toasters, they glow, they light up, and the waste energy there is the light. Okay, so you have to think about each situation separately. But let's go back to our filament lamps here, or two different lamps. We've got a filament lamp. Now that's a normal lamp that you see. It's got a bit of a wire there, and it looks like this, and it's my really bad drawing of a lamp. Okay, now a filament lamp just works by heating up this wire, and you heat it up so it becomes so hot that it glows. Okay, so by definition, because you're making it heat up, a lot of the energy is wasted as heat here. Okay, they're about 20% efficient, and that means that 20% of the energy that goes in, the electrical energy that goes in, comes out as light, and the other 80%, because remember percentages have to add up to 100, is wasted, and it's heat. Okay, it's wasted as heat. So if this was, for example, a 60-watt light bulb, okay, 20% of that, so that would be 12 joules per second, or 12 watts, would come out as light. And 80%, which is 60 minus 12, which is 48 watts, 48 watts would come out as heat. Okay, or 12 joules per second, or 48 joules per second, if you want to think of it that way. Now, energy efficient light bulbs, those ones that they're usually, I can't even draw one, but they're made of like tubes that look really funny and weird. I'm not going to be able to draw it very well at all. It's a very bad representation. It's got tubes of gas in. That's meant to be my example there. Okay. Now they're 90% efficient. This is why they're energy saving lights, because they use less energy. They don't waste as much. Okay. Now 90% efficient means that 90% of their energy that goes in comes out as light, and only 10% comes out as wasted heat. Okay. So for this same thing, if we had a 60-watt light bulb, 90% of that, so 54% or 54 watts, sorry, would be converted to light, and only 6 watts would be converted to heat. And that's why normally energy-saving light bulbs, you don't have such high wattages. You usually get about 12, 20 watts, because you don't need as much, because you're not wasting as much of it. Okay. So there's an equation we can use to work out efficiency, and it's this one here. Efficiency is the useful energy out divided by the total energy in to a device. And we times it by 100% because we like efficiency in percentages. Sometimes it would ask for it as a decimal. If it asked for that in a question, you just wouldn't times it by 100%. You just leave it as a 0.3 or whatever you come out as. Okay. So the easiest way to think about this is to look at an example. And we've got here that a car uses 1,000 joules of energy. It used the total energy in. 100 joules is converted into sound. 400 joules is converted to heat. The rest is converted to kinetic energy. How efficient is it? So we know that we need to look for the useful energy out. Now, a car's useful energy is clearly movement energy, because a car helps things to move. Now, that's also known as kinetic energy. So this is the useful stuff. Okay, but it hasn't told us how much there is, but we can work it out, because the total energy has got to equal the useful plus the waste. Now, in a car, the sound and the heat energy are waste energy. We don't really care about them. We get them, they're byproducts. So we know that the total energy in 1,000 joules, 1,000, is equal to the useful plus the waste, which is 100 for sound and 400 for heat, okay, which is equal to 500. So 1,000 is equal to useful plus 500. So the useful energy must be 500 joules. Okay, it's 500 joules that is converted into kinetic energy. So now let's look at our equation. We've got that efficiency equals the useful energy out, which we've just worked out as 500 joules, divided by the total energy in, which we were told at the start is 1,000. That would technically be chemical energy because it's in petrol. And we times that by 100%. Now 500 divided by 1,000 gives me 0.5. That's the decimal version of efficiency. Times by 100%, which is quite clearly 50%. So this engine is 50% efficient. For every joule of energy put in, you only get half a joule of energy usefully out into movement. Everything else is wasted. And that's probably quite typical for cars. They're not particularly efficient engines. Okay. Now, let's have a look at this question here. A kettle is 90% efficient. It takes 1.5 kilowatts of power from the mains. How much power is wasted? Okay. So remember that 1.5 kilowatt hours, not kilowatt hours, just 1.5 kilowatts is just equal to 1,500 watts. Remember, a kilowatt is 1,000 watts. And the kettle is 90% efficient. And that's because the most normal thing to be wasted, well, the most normal type of energy that's wasted is heat. And a kettle wants heat, so it's not bad. So 90% of this power is used usefully. 90% of 1,500 is equal to about, I have to do this in my head very quickly, each 10% is 150, so that's equal to 1,350 watts. Okay, so 1,350 watts is used to heat up the water. Now 10%, if it's 90% efficient, that means that 10% is wasted. So 10% of that, equal to 150 watts, is waste. Okay, so it wastes it wastes 150 watts of power, or 0.15 kilowatts of power. Now that means that every second we waste 150 joules of energy. Now that waste is going to be sound energy. You can hear when a kettle boils, it makes some noises, and also it's when it heats up the plastic of the kettle and not the water. So this is the useful energy is heating the water, the waste energy is heating the plastic and the surroundings of the kettle. Okay, so that's a simple question on efficiency. The big thing to remember is it's useful energy out divided by the total energy in. Now you can, if you want to, as we've just done, instead of writing energy, we can use power instead. So if you get given power values, you can use those as well. And one way that we look at efficiency is more graphically is through Sankey diagrams, which we'll look at in the next video. So have a watch of that if you need it.